channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. Students, I promise you to complete your syllabus and would like to solve all your queries which you may drop in my comment box. In my last sessions, we have discussed about set theory. Today we continue with this. Now let us discuss about what is subset. Now let us discuss what is subset. Think about what is subset. Subset is, suppose A be the set of, let A be the set of English alphabets. A be the set of English alphabets. Then let us consider B be the set of vowels. B be the set of vowels. Then here B is the subset of A. This means all elements which belongs to B must be an element of A. Now look at here. Suppose B is the set of vowel means A, E, O, I, U are the elements of the set B, where A is the set of English alphabets means it contains all A, B, C, D, E up to Z. Then as A belongs to, when A belongs to B, this implies that A also belongs to the set A. Suppose E belongs to B, E belongs to B. This means E also an element of A. Here B is the, let's keep it here and discuss about this. What is subset? Keep it here. B is the, this means the subset B is the subset of A. This means all elements which belongs to, please students note down the important things. All elements which belongs to B must be an, belongs to B must be an element of A. In this case, we say that B is a subset of A. Now let us discuss about theorem 1. What is theorem 1 says? What is theorem 1 says? Here the theorem 1 says, students, be attentive in my class. I promise you to complete your syllabus and would discuss all the questions in depth in board level, and for JEE mains, all the chapter will be covered in depth. If you have any doubt, please ask me in my comment box. I am ever ready to clear all your doubts. And after completing the chapter, I will discuss about the important board level questions and also the important JEE main level questions. Please be attentive in my class. Follow my class thoroughly, and if you follow my class regularly, I promise you, you should not need any extra classes. Now let us discuss what is theorem 1 says. Theorem 1 says that every set is a subset of itself. Theorem 1 says every set is a subset of itself. What do you mean by subset of itself? Let us prove. Every set is a subset of itself. Let us prove. Let A be any set. Let A be any set. Let A be any set. Then each element A belongs to A must be an element of A. Must be an element of each element which belongs to A. This also belongs to A. This means A is a subset of itself. The set A is also a set of itself. This means each set, every set is a subset of itself. This is theorem 1. This is theorem 1. Now what is theorem 2 says? What is theorem 2 says? Let us keep it here and discuss about theorem 2. What is theorem 2 says? The theorem 2 says that the empty set is a subset of every set. The theorem 2 says that the empty set, what do you mean by the empty set? Theorem 2 says that the empty set, is the subset of each. The empty set means the subset of each set. Now let us discuss, keep the line here. Now let us think. The empty set means the null set. Empty set means the null set. What do you mean by null set? In my last sessions, I have discussed about null set. Null set means phi. Means nothing belongs to this is the empty set. The empty set is subset of itself. Subset of each set. This means if you take an empty set, means phi is an empty set. This means nothing is found in this set. This is always a subset of every set, means every set. If A belongs to alpha, null set, A belongs to null set. This is not possible because nothing is present in a null set. If A belongs to a null set, this implies that A belongs to any set. This implies that A belongs to any set. This means null set is a subset of each set. Okay. Now let us discuss about what is theorem 3 says. Now let us discuss what is theorem 3 says there. The theorem 3 says that, students, be thorough about the theory. When you thorough about the theory, then there will be no problems to attempt any types of problems you get in your exam paper. Okay. Then theorem 3. What is theorem 3 says that? Total number of subsets of a finite set containing n elements is 2 to the power n. This theorem 3 says that the total number of subsets of a finite set. You know what is finite set? Finite set means the number of elements in the set present is a counting number. Means finite number of elements present in the set. The total number of subsets of a finite set containing n elements, n number of elements is 2 to the power n. The total number of subsets found in a finite set which contains n number of elements is total number of subsets is 2 to the power n. Now let us prove the theorem. Now let us prove what the theorem says. Now let us prove. Let A be any finite set. Let A be any finite set. A be any finite set. Students, please note down the important points. Let A be the finite set which contains n number of elements. A be the finite set which contains n number of elements. Then number of elements. Then let R be the number of elements present in the subset where R is greater than equal to 0 and less than equal to n. R be the number of elements present in the subset of the finite set A, where R is the number which is greater than equal to 0 and less than equal to n. Means R equal to 0, R equal to n, R equal to 2, up to R equal to n. This means there are number of subsets which presents in the finite set A which contains the number of elements may be 0, may be 1, may be 2, may be 3, may be 4 up to n. Then the subset of A that are n number of elements each. We know that keep it here. Then the subset of A that are R number of elements each. We know that the number of way in which R elements can be chosen. The number of way in which R elements can be chosen, R elements can be chosen each. R equal to maybe 1, maybe 0, maybe up to n. Hence, by the total number of subsets present in the, then the total number of subsets present in A is denoted as Cn0 plus Nc1 plus Nc2. In this way, this is equal to Ncn, where this by applying binomial theorem, then using Cnn, then by using binomial theorem, just recall what is binomial theorem. Then by using binomial theorem, this is equal to 1 plus 1 to the power n, which is equal to 2 to the power n. This thing we have to prove that the set which has finite number of n elements present have the number of power set is equal to 2 to the power n. Hence here we prove that let A be a finite set which contains n number of elements. Let R be the number which is between 0 and n, means the R is the number of elements present in the subset of A. R can be chosen, R may be 0, 1, 2, 3 up to n. Then the total number of subsets which presents in the set A containing the elements may be 0, may be 1, 2, 3, 4 up to n. Then by using binomial theorem, this is the number of elements present. This is N0, C0, NC1, NC2, and up to in this way NCN. Up to this NCN. Then by using binomial theorem, we get this is 1 plus 1 to the power n, which is equal to 2 to the power n. Hence, we prove the theorem 3. Now, let us discuss some examples. The example says that suppose the finite set have m and n. Now, let us discuss some examples. What is the question says? At first, think what the question says. Here, the question says two finite sets have m and n elements. Here, two finite sets having elements m and n number of elements present in it. Having the number of elements present m and n, then total number of subsets first set is 56. Then the total number of subsets of first set. Then the total number of subsets of set 1 is equal to 56. And next the question says 56 more than is equal to 56 more than total number of sets of total number of subsets of second set. 56 more than total number of subsets of set 2. Here the question says that two finite sets presents having elements m, number of elements m and n. The question says that the total number of subsets of set 1 is equal to 56 more than the total number of subsets of set 2. This means according to question the solution says that then A be the elements, let A be the set with elements m number of elements m number. Then B be a set with n number of elements Then according to questions, as we know that by applying the theorem 3, the number of subsets of A is equal to 2 to the power m and the number of subsets of B is equal to 2 to the power n. Then according to questions, 2 to the power m minus 2 to the power n is equal to 56. According to the questions, the number of subsets, the difference between the number of subsets of A and B, 2 to the power m minus 2 to the power n is equal to 56. Then keep it here and now discussed. Then now let take it. Take 2 to the power n common, then we get 2 to the power m minus n minus 1 is equal to 56. This is 2 to the power n into 2 to the power m minus n minus 1. 56 can be written as 8 7 ja. Then 8 can be written as 2 to the power q. 7 can be written as 8 minus 1 means 2 to the power q minus 1. Then this is 2 to the power n into 2 to the power m minus n minus 1. Then by comparing the exponents, both sides, comparing the exponents of both sides, we get 2 to the power n is equal to 2 to the power 3 and 2 to the power m minus n is equal to 2 to the power 3 minus 1. 1 cancel means 2 to the power m minus n is equal to 2 to the power 3. This means n is equal to 3 and m minus n is equal to 3, which implies that n is equal to 3 and m is equal to 6. Then we come to the conclusion that here the value of n is 3 and m is 6. Now let us discuss the examples from the starting. Here the question is given, two finite sets are given having elements m, number of elements m and n number of elements present in the finite set, and the question says that the total number of subsets of set 1 is equal to 56 more than the total number of subsets of set 2. Then here let A be the set having element m number of elements and B be the set having n number of elements in it. Then according to the questions, the difference between their number of subsets is 56. This means 2 to the power m minus 2 to the power n is equal to 56. Then let n be the small and m be the greater number. Then taking 2 to the power n common, then we get 2 to the power m minus n minus 1 is equal to 56. 56 can be written as 8 7 8 into 7. Then in place of 8 we can write this is 2 to the power q. In place of 7 we can write 7 is equal to 8 minus 1, which is 2 to the power q minus 1. Then by comparing the exponents we get 2 to the power n equal to 2 to the power 3, 2 to the power m minus n is equal to 2 to the power 3, then we get the value of n equal to 3 and m minus n equal to 3. This means m is equal to 6. Then by solving these examples, we come to the conclusion that the value of m is 6 and n is 3. Okay. Now let us discuss another examples. Now let us discuss another examples. I have already told you, please practice variety of questions, students. You should do your worksheet and ask me your doubt. I am ever ready to clear your all doubts. Now let us discuss what is example 2 says that. Here example 2 says that if x is equal to, here example 2 says that if x is equal to the set of where 4 to the power n minus 3n minus 1 such that n is a natural number. N is a natural number. 4 to the power n minus 3n and y be the set is which is equal to 9 into n minus 1 such that n is a set of natural number. Then here we have to prove that x is the subset of y. The x is the subset of y means every element of x must be an element of y. Now let us solve. Let us solve the solution. Let as x is equal to 4 to the power n minus 3n minus 1, then let x n, nth element of the set x is equal to 4 to the power n minus 3n minus 1, where n is a natural number. N is any natural number. Then when you put x n equal to 1, x of 1 is equal to 4 minus 3 minus 1 which is equal to 0. Then for any n is greater than equal to 2. Here when we take n equal to 1, we get the value of x is equal to 0. Then for any value n is greater than equal to 2, then x n is equal to 4 to the power n minus 3n minus 1. Then this 4 to the power n can be keep it here and now discussed. Keep it here. 4 to the power n minus 3n minus 1. Then 4 to the power n can be written as 4 to the power n can be written as 1 plus 3 to the power n minus 3n minus 1. Then by applying binomial theorem, then xn equal to this. By applying binomial theorem, this is nc0 plus nc1 plus nc1 into 3 plus nc2 into 3 square plus nc3 into 3 cube. In this way we get ncn into 3 to the power n minus 3n minus 1. Then by applying binomial theorem, we get that this is nc0 is equal to 1 plus nc1 into 3 is equal to 3n plus nc2 3 square plus nc3 3 cube. In this way, this is ncn 3 to the power n minus 3n minus 1. Here 3n minus 3n cancel, 1 cancel. Then this is equal to nc2 3 square plus nc3 3 to the power cube In this way, this is NCN 3 to the power n. Then you can taking common as 3 square, taking common you get this is NC2 plus NC3 into 3 plus in this way this is plus NCN 3 to the power Cn 3 to the power n minus 2. Then this means 3 square means this is 9. This is equal to 9 into NC2 plus NC3 3. In this way this is NCN 3 to the power n minus 2. This means this is a number which is multiple of 9. This is the number which is multiple of 9, which implies that here look at here y is the set which is a multiple of 9, and here we get x is the element which presents in the set of x is also a multiple of 9. Here also the y is the set which is multiple of 9. Hence we come to the conclusion that x is the subset of y. Hence we come to the conclusion that x is the subset of y. Okay. Now look at here. If you have any doubt, students, look at here. Here the question says that x is the set which where x is equal to 4 to the power n minus 3n minus 1 and y is equal to 9 into n minus 1, where n is any natural number. This means y is the set of multiples of 9. Then here by solving we take the xn, then by solving this we come to the conclusion that the elements which presents in x is also a multiple of 9. This means the elements which present in x must be an element of y. This means x is a subset of y. Okay, clear? Clear, students? If you have doubt, please ask me in my comment box. I am ever ready to clear your all doubts. Okay. Now let us discuss what is subset. What is the variety of sets? N is the set of natural number. N is the set of natural number. Set of natural numbers. You know what is natural number? Natural number means counting numbers. 1, 2, 3, these are all counting numbers. W is the set of whole numbers which contains all natural numbers and including 0. This means n is the subset of W. And here Q is the set of integers. Q is the set of rational number. Z is the set of integers which contains negative integers and positive integers. -1, 0, 1, 2, 3. In this way, Z is the set of integers. Look at here. N is the subset of W and W is also a subset of Z. Z is set of integers. The Z also contains the whole number set W. Then here Q is the set of rational number. Set of rational number means x upon y in such a way that x and y belongs to the set of integers, belongs to Z, where y is not equal to 0. If you get 0 in the denominator, means this number cannot be defined. We get infinite means undefined number. Then Q is the set of rational numbers. Here we get that, keep it here and discuss. Here we get that the Q is the set of rational number. Then let R be the set of real number. Q is the set of rational number. Then let T be the set of irrational number. Set of irrational numbers. This means the number which cannot be defined in x, y, y form. Irrational number. Irrational number. Then let R be the set of the set of real numbers. Real numbers. Then here T is also a subset of R, but T is not a subset of Q. Here we come to the conclusion that the N is the subset of W, W is the subset of Z, Z is the subset of Q, and Q is the subset of R. But here the irrational number may be the subset of real number, but not the subset of rational number, natural number, whole number, etc. Okay. Now let us discuss what is closed interval, what is open intervals. Now let us discuss what is closed interval. Closed interval means suppose AB is the closed interval. Suppose here AB is the closed interval denoted as AB, the closed interval. This means suppose X is a number which belongs to the closed interval AB. This means X is greater than equal to A and less than equal to B. This is the closed interval. Suppose here AB is the closed interval which is denoted as X such that X is greater than equal to A and less than equal to B, and it is denoted in the real number line in this form. Suppose this is minus infinity to plus infinity, then here A and B are closed intervals. X presents in between them. Closed intervals means greater than and less than. This means the interval contains A and B. Then open interval A and B is the open interval, which means that X is such that, X is greater than A and less than B. This is the open interval, and this is denoted, suppose this is the real number line and this is up to minus infinity to plus infinity, then this is open interval, this is A and B, then X belongs to between A and B. This is the open interval. The closed interval includes A and B. The open interval doesn't include A and B. This is greater than A and less than B. This means X is between A and B. Then what do we mean by semi-closed or semi-open interval? Suppose A, B. This is a semi-open or semi-closed interval. This means look at here. Then semi-open or semi-closed interval, suppose A, B is the semi-open or closed interval. This shows that X is such that X is greater than equal to A and less than equal to B. And suppose here this is also a semi-open or semi-closed interval. This means X is such that X is greater than A, and less than equal to B. This can be denoted in the number line in this form. Suppose A and B, semi-open or closed interval, this can be denoted. Suppose this is real number line from minus infinity to plus infinity, then here this is A, and this is B. This is semi-open or semi-closed interval. This means X belongs to from A to between B, not include the B. And in this case, this is the number line in this way. This is the real number line in this way. Up to minus infinity to plus infinity, X is, then this is here A and here B. Then X is between A to B, which includes B but not include A. This is semi-open or semi-closed intervals. Okay. Then students, today this much. In my next sessions we will discuss about what is universal set and what is power sets. Then thank you students. keep learning and share my beautiful channel with your friends. Okay, thank you students. Have a